Any questions before we start? There's a QR code on Moodle to register your attendance if you want to do that. I like to walk around, so I don't like chairs in the way. Everybody get their Git clients and GitLab working yesterday? If not, have a look at the screen capture demo. That should help quite a bit. Okay, so last time we talked about version control, Java talk, and identifying objects. Can anybody explain how to identify objects given a requirement specification? Anybody want to try to answer that question? Anybody feeling super ambitious and intelligent and I don't know, courageous? You're so lucky I don't know your names. If I knew all your names, I would just start calling on people by their name, and then you wouldn't be able to escape. Okay, so last time we talked about these very fundamental, important questions. Right, we described what an object is, some terminology. We went into these messages, behavior, methods, signature. We talked about classes versus instances. We looked at a typical class hierarchy. And then we looked at this overview of the object-oriented design process, which was initial exploration, detailed analysis, and then subsystem identification. We talked about the initial exploration. Everybody knows that this slide is very important. It could even be useful, for example, on a test. And then we talked about the analysis phase, identifying subsystems. We're going to have a special lecture dedicated to that topic. And then we looked at client-server terminology, what a contract is. A contract, by the way, just means two classes are communicating with one another. That's all it is. Okay, so today we're going to talk about responsibilities. You're responsible for knowing this stuff. And by the way, just a little step back in the grand, bigger picture, these lectures are all about going from the specification, which usually comes, not always, but usually comes in written form, like the snake game that you're working on now. Going from that phase to the implementation phase. There's a design phase in between, right, where you're actually trying to figure out how to organize your software. And now that you have your coursework, if the software, you can see if the software is not well organized, it's very difficult. It's really difficult to understand someone else's unorganized software, right? So responsibilities. By the way, you can think of objects as nouns in the requirement specification, and responsibilities as verbs in the requirement specification, or data or information. So there are two kinds of responsibilities: knowledge maintained by an object and actions performed by an object. So methods, right? and they represent the purpose of an object or the system. They define services provided by an object to the system. That word system means the application as a whole, right? The whole program, right? In your case, it's the snake program. So information can be returned to a client object, or an action can be performed for a client object. And they represent publicly available services. So services that are visible outside the scope of the class. Right? You have, in Java, you have private and public methods and data. Right? So they represent the public aspect. You should basically never have private data. And during the design phase, I have this in bold-face font. You concentrate on what a class does, not how it does it. So just concentrate on what it does and not how. Anybody know why that is? Why do we concentrate on what a class does and not how? Anybody want to attempt to answer that question? It's a very difficult question, actually. You have to really know what you're doing. Is it Sean?
Yeah.
Sean, why is that?
But you don't know how, because a lot of times, if you're having a problem, you might be the how.
That's true. During the design phase, we're talking about what.
Oh, the design phase.
This is the design phase. Yes, we're talking about what each class does, not how it does it. What's your name?
Peter.
Peter.
The how could change. So
Yes, that's definitely true, because the how can change. Another way of saying it is there are many different ways we could implement something to get it working. That's another way of saying it. So we don't want to worry about that during the design phase. In fact, another way of saying is there are an infinite number of ways how something can be implemented. Like there's no limit to the number of ways something can be implemented. So if you get into a discussion with somebody about how something should be done, that discussion will never end. It may never end, so it's not useful. You don't really want a discussion that never ends, right? Ultimately, how is that resolved? In reality, if you have a well-organized project, every object in class is assigned to a person, and that person decides how. Right? It's the person assigned to that class that decides the how. But as a team, you can decide on what each class does. So this is a very important slide. Like, put a little asterisk on the slide. I don't know how you remember these things, whatever you do. So guidelines for identifying responsibilities. Now, this is again, imagine you have a requirement specification like Snake, and now you're trying to figure out what the responsibilities are, how to identify them. We had a slide like this called Guidelines for Identifying Objects, and now we're having another slide called Guidelines for Identifying Responsibilities. So examine verbs in the requirement specification, right? Verbs correspond to methods in a class, right? Each active voice verb may indicate a responsibility. Turn a passive voice sentences into active voice and examine. Then look for information nouns in the requirement specification, right? So for example, like in your snake game, a snake is going to have a length. That's some information, right? It's going to be some value that has to be maintained, right? So this may become an attribute of a class or part of a composite class. Information words can imply how much, how many, how big. Any other information nouns in your snake game? Can anybody think of another one besides Sean? I'll let Sean speak if nobody else wants to give it a try. Any other information nouns? Sean, what do you think?
Food.
Who?
Food.
Food.
Yeah, food.
Food, like the snake. Okay, like how much food, for example, how often.
Oh, sorry.
Yeah, this is like information nouns. How often or how much, right? How many pieces of food? Well, you could have a snake game with multiple pieces of food. The other information might be like the height and the width, right, of the canvas that you're playing on. So how wide, how high, maybe that changes. That could be a strange. How wide the snake itself is, how big the food is, right? There are lots of information nouns that have to be managed, right? Those are all attributes. Perform a system walkthrough. That's called a use case in UML. Postulate a variety of scenarios and execute the system. So that means like, think about how the thing is going to look like. Do a walkthrough, right? Scenarios should be based on a functional view, right? In other words, the perspective of the user, somebody using the system. Look for places where something happens based on system input, right? In the snake game, I guess it's the arrow keys that are the input, something like that. And there'll be some mouse input for like choosing, I don't know, skill level, maybe saving a game into storage and so on. Has each action been noted and have responsibilities for each action been identified? And then, once we've identified the responsibilities, we have to re-examine the classes that we identified in the previous exercise. And then we know that for every class has at least one responsibility. The name of the class may imply responsibilities. A statement or purpose may imply responsibilities, and attributes of the class have to be managed, right? Those information nouns like length, width, height, depth, how often, those all have to be managed. Anybody know how those are managed, the information nouns? I'm asking a lot of advanced questions these days. If you can answer my questions, you're gonna like be a hero, basically, and you're going to just conquer the world. Attributes of the class may need to be managed. Anybody know how they're managed besides Sean? Anybody want to? Name? Matthew.
Public and private.
Public and private what?
I forget the specific word, visibility.
That's getting one step. There's like three: public and private. That's one part, and then there's two more parts. Think job interview. Name?
Setters and getters.
Exactly. Accessor methods. What's your name?
Yusuf.
Yusuf. Thank you. Thank you, Yusuf. That is a great answer. Yes. So once we've identified the responsibilities, we assign them to classes. Right? Examining context, each responsibility, the use case requirements, and class definitions. So we start putting those responsibilities in their classes, and we have to figure out some ways to do that. Firstly, we want to distribute the responsibilities and try to distribute them evenly. Right? State responsibility as generally as possible. Keep behavior with related information. Keep information about one thing in one place. And share responsibilities among related objects. Anybody know why we keep information about one thing in one place? Any ideas why we do that? Keep information about one thing in one place. I mean, you could name Gone? Ronald.
Yeah. To avoid redundancy.
To avoid redundancy? Yes, that's correct. Any other reasons? So, what were you going to say?
Improves modularity, so you only need to change it in one place.
That's correct. That's very correct. Any other reasons? Those are two good reasons to avoid redundancy. And the other reason is to avoid inconsistencies. So if you imagine you have information about something in two places, it becomes inconsistent, or it's probably going to become inconsistent, right? So we want to avoid that. And keep behavior with related information. I mean, this is the core concept behind objects. What defines an object, right? Its behavior and the data it needs associated with that behavior, right? Distribute system intelligence evenly. Where can you see an example of that taking place? Like, where have you seen that principle already? Anybody? I'm asking lots of difficult questions today. I guess it's kind of difficult. Have you seen that principle already? Like, seen it in front of your face being applied? Yeah. You have. The answer is yes, you have. I guess another question is, where have you seen this in front of your own eyes being applied? It's in the Java API. Remember we looked at the Java API last time? That long list of objects, it's very long, isn't it? It's really long. I don't know how, anybody know how long it is? It's probably like 1,000 objects or something, or 2,000 or something. Does anybody know how many objects are there? Anyways, that is this principle being applied. Like, you can see the Java API, it's following all those guidelines and it's distributing the intelligence and the responsibilities amongst the different classes. Right? So thinking in terms of intelligence, intelligence you can think of in very concrete terms. How many methods a class has and how many member variables a class has. The more methods and the more variables it stores, the more intelligent it is. That's the way you can think about that. So thinking in terms of intelligence at a more abstract level, what the system knows, what actions the system can perform, the impact the system has on other systems. And if a class is too intelligent, it can cause problems. So if a class is too big, it can cause problems. Class intelligence is determined by two major components: what service it provides and what services it uses. Here's another advanced question. If a class is too intelligent, does it have a big or a small impact on the rest of the application? Anybody want to try to answer that one? Nate?
Zachary, would it be smaller because all the functions are actually going to be carried out elsewhere? It would have a big impact because it will be calling everything, but wouldn't it have a smaller sense of all what's calling is actually written elsewhere? But it would be more intelligent because it's calling everything, or what's your opinion?
I would, the way I see it is if the class has too much intelligence, it has too great of an impact on the rest of the system. Because changes to that class might affect lots of other classes. That's the way I see it. You kind of want to avoid a situation where you can modify one class and it breaks everybody else. Like that's the basic message, Sean.
But what about if it just needs to be like that? Because like, especially like, think about like a video game with player characters, probably a big class, but when you're gonna break the player characters in multiple classes, it's a thing.
Exactly. No, you're right.
Yeah.
You want to subdivide it. You want to think carefully. If you're a really professional, like you're like a high quality developer, and you notice your class getting too big, you want to sit down and say, this is getting too big. I need to subdivide it. I need to think about my organization further on how to subdivide this thing, introduce new objects.
So then can we get to the state where you're trying to implement functionality and you kind of figure out where in your player class, which you divide divvied up, where the functionality is.
That's right, that's right. That's exactly right. So what Sean is saying is we have to really think about how we're organizing objects and methods. You don't just have one hello world class and have all the methods and things in there. You have to think very carefully. And like I had a job as a software developer and I spent a lot of time. I didn't just type the whole time. I had to sit down and think, like, how is this going to be organized? What objects do I need? And sometimes, basically, what happens is you're implementing things and you discover this class has gotten too big, right? It takes too much time to scroll up and down these 1,000 lines of code. I can't find things anymore. I'm struggling to find things. And when I make a change here, it's having too great of an impact on other places that I can't understand. And these are all signs that your classes have too much intelligence. And it can get very frustrating, actually. So there's a server view of intelligence, what the class knows and provides to clients, what actions it can perform, and there's a client view of intelligence. How many classes does a certain class know about? Like how many other classes? How many other classes does it collaborate with? And how much does it need to know about those other classes? So some examples, collection objects like arrays and sets have low intelligence, right? You can have an array or a vector or something like that, and it doesn't have to know very much about what it's storing. It just has to manage the array, like how to append items onto the array, how to remove items from the array, how to find, search for items in the array, and so on. But another example would be the drawing editor class has high intelligence. It knows a lot about other classes. So in these slides, it refers to this hypothetical example of a drawing editor. So a program that you can use to draw figures, like squares and triangles, edges, circles, and so on. And I think you use something kind of like that. Right, what is the program that you're using to draw the UML diagrams and stuff? Isn't there a program that you guys are using?
The visual studio.
Yeah, that one. So something like that. So that class, the main method, or the class that has the main method of that application is going to have a lot of intelligence. That's a difficult one to, let's say, workaround, but the workaround for that is subsystems, right? The main class is going to initialize the GUI, it's going to initialize the storage, right? If the storage is in files or if it's over a network, it's going to initialize the display, it's going to initialize the drawing area, it might render things onto the drawing area. So it's going to have a lot of intelligence, and that intelligence can be managed with subsystems, which is what we're going to talk about later. Okay, we're going to talk about this general notion of centralized intelligence, the CIA. Everybody, I always think of the CIA when I see this slide. So if we think about the extreme example, we can think about one class, one object, all of the methods are in that class. And you can even think about it in another sense. You have just one method. It's the main method, and that's it. And you have just your whole execution from top to bottom in one method. That's sort of the most extreme example of centralized intelligence. That would be a fun exercise, wouldn't it? You know what, that would be a really, really great exercise to say, okay, I want you guys to write two programs, two snake programs. One follows these guidelines, and the other one has one method, a main method, and no other methods. How much fun would that be? That would be so much fun. You'd be so happy. However, there is one advantage to having one method from top to bottom. Maybe it's 5,000 lines or something. There is one advantage to that. Can anybody think of the one advantage to that approach? Which is like the start of programming, right? The start of programming was one method from top to bottom. Fortran is like that, isn't it? It's kind of like that. Has anybody ever seen Fortran? It's an older programming language. Sean, what do you think? What is the advantage of that?
You get to see what's going on, it's a lot easier to see that happen.
Why do you know everything, Sean? Were you a software developer or something?
I research stuff.
You were never a software developer already, were you? In a previous life? Yes, so the advantage of centralized intelligence, one method from top to bottom, maybe it's 5,000 lines long, is it's easy to follow. You know, okay, this line is being executed, then this line is being executed. It's easy to follow the way the program, well, it's easy to follow the order of instructions. That's the advantage. You can see the flow of the program easily. You can just follow the order of the program. You know what's happening, when it's happening, and which order things are happening. You could also say you can track the flow of information easier. That's another way of saying it, or the flow of execution. Oh, it's right here on the slide.
Yeah.
Easier to get initial understanding of the overall control of the flow and information flow. So this is the difficult part of object-oriented design and methodology. As you already, I think, once you start working on the snake program, you already can see this, like, the intelligence, the behavior, and the flow is moving around from one object to another, and it's hard to understand. It's hard to follow what's going, the flow of execution. Sean?
Isn't like that the hardest part of programming? So why would we want to use object-oriented programming to make it harder to solve the hard problem?
That's almost like a philosophical debate in some ways, but I would say the short answer is because now we have, let's say, a systematic way to organize the information. If you look at the software from an organizational perspective, it's just because now we can understand organization, but it decreases our understanding at the expense of the flow. There's a trade-off, so it's not 100% win. You know, there's a trade-off there. And the other thing I could say is it's a consequence of the software getting bigger. Just like the libraries, right? If you walk into a library with 100 books, you can store the books next to each other, like in random order, it doesn't matter. But as soon as when you have 1 million books, suddenly it's difficult to find the books. You have to figure out. But imagine in the library metaphor, like if you walk into a library with 1 million books and I ask you how is this library organized and what's the flow of information in this library, it's a difficult question. Like You'd have to work there.
Yeah, but like, you can organize things other than object-oriented programming.
That's true, yes, there are other ways, yes. By the way, another a really advanced concept that we don't talk about in this module, and most people don't talk about, is if your system is designed really well, it's treated in a sort of organic perspective. In other words, no object is automatically assumed to actually work. So you're always testing, like from a client perspective, I just asked a question, I just requested a service from another object. Did it actually work? And how do I handle the scenario when it's not working? So if every object is designed from that perspective, the whole system will keep functioning if some objects are broken. That's another advantage, I would say, of object-oriented design. So some of the disadvantages of centralized intelligence is it's so-called hardwired system behavior. It makes it less adaptable. Right? If I have one class with one main method, I can't reuse any of the code. Right? I can't do Snake version 2 or something and extend the main method with a subclass of child class called Snake version 2 or whatever. I can't reuse any of it. Right? It integrates multiple design decisions into a single class. And if you make a change to that main method that's 5,000 lines long, you're scared, right? Because you're thinking, oh my gosh, what if this change affects something 1,000 lines below where I am now? How am I gonna know that? Well, you're not gonna know that, generally speaking. How many slides do we have left? I could talk a little bit more. Okay, so I think I can mention this. You'll see this in industry, by the way. I have seen this in industry. This is exactly a symptom of this problem of not understanding how to organize software. What happens is somewhat like a method, you have an important method, and developers or a single or multiple developers will modify the method, and it keeps getting longer. Like it starts out as 20 lines, but every time it's modified, it's extended by 10 lines. And you can end up with a method that's 1,000 lines, or 2,000 lines, or 3,000 lines, and you have to scroll for a few minutes to get up and down. There's a magic point at which the method becomes so long, everybody is scared of it. They don't want to touch it anymore because they're afraid, oh my gosh, it's so long, I can't touch it anymore because I'm afraid I'm going to break it. What if I'm the one that checks out that file, makes the modification, and breaks it, and I can't figure out how to fix it because it's 1,000, 2,000, 3,000 lines long? Nobody wants that burden anymore, so they don't touch it anymore. It's untouchable, right? If a method gets too long, it becomes untouchable, and it can't be modified anymore. It's like a stack of cards that has gotten so high, or the Jenga game, nobody can touch it anymore. The Jenga is a very good analogy, actually. Right? When the Jenga tower gets too tall, it gets too fragile, and everybody's afraid to be that next person that takes that's exactly what happens when a method gets too long. That's exactly what happens. Does anybody know what that method turns into? What that's called? There's a special name for this phenomenon. When the code is so big and so scary that nobody can touch it anymore because they're going to break it. Anybody know what that's called? There's a special name for that kind of source code. That's not going to be a job interview question, by the way. Name?
Rory.
Rory.
Is it a God object or something else?
It's called legacy code. You might have heard that term. Legacy code. Can't be touched anymore. Can't be modified anymore. It just has to sit in the version control system forever. Because nobody understands it anymore. And I'm not joking. You're going to see this a lot if you have a software development job. One of my students that graduated, it was really funny. I asked a PhD student that graduated, how's your new job? And he had to take my software engineering class. And he said, you'll never believe it, Bob, but there's code here from 1985. 1985 in this thing. No joke. That's called legacy code. In fact, most code that is in existence is legacy code. That's the reality. Yeah. Okay. Distributed intelligence. So this is what you see when you look at the Java API, right? Distributed intelligence as evenly as possible among classes. So we minimize the number of intelligent classes, all with the goal, I mean, this is a theoretical goal, it's not really possible. All classes are equally intelligent, but that's the goal. Right? Each object knows relatively little. Each class encapsulates only a few related design and implementation decisions. Right? You can look at the Java API and you just see some nice examples like a time object or a cursor object, or a frame object, these kind of evenly distributed intelligent objects. So if we want to examine the intelligence and its distribution, we count the number of responsibilities that each class has, right? We don't want too many responsibilities in a given class. And this is what Sean said. If a class has a particularly long list, maybe the responsibilities are expressed at too low a level of detail. Maybe responsibilities have to be moved to other classes, or maybe the class needs to be subdivided. Yeah, like in the player example, player is not, I can't really imagine player being like this super intelligent class. But one way to think about that could be like, okay, if I have a player class, how can I distribute the intelligence a little bit more? Well, maybe I have different kinds of players. Maybe I have like beginner level player, advanced player, or maybe I have like player that's a child in different age groups or something like that. So there are ways, okay, here's an example, like maybe you decided that the player has historical information, and maybe the historical information has gotten out of control. So you can introduce a class called player history to try to distribute the intelligence. But when you get experience, you'll get a feeling for these things. Like you open up an object and you're spending too much time scrolling up and down looking for things. Like it's just become too big. And you'll just get a feeling like, this has gotten too big. And you'll know, I need to introduce some new objects. So, some responsibility guidelines, state responsibilities as generally as possible. So instead of stating that a line element knows how to draw a line and how a rectangle element knows how to draw a rectangle, we say that both know how to draw themselves or draw itself. Again, this is that drawing editor example. In a drawing editor, you can draw edges or you can draw a rectangle, right? So instead of saying like line element, draw line element, or rectangle element, draw a rectangle element, we would just have a method called draw. Like line.draw or rectangle element.draw. They know how to draw themselves. So that leads to more shared responsibilities. If we have a line element that knows how to draw itself with a method called draw, and we have a rectangle element with a method called draw, we can then introduce a parent class, right, called drawable object, and it has the responsibility of drawing itself. Right? So that's what this line means, leads to more shared responsibilities. This can lead to more general classes like drawable object. Keep behavior with related information. So that's again, going back to that fundamental principle of object-oriented methodology and what is an object. An object is just a set of methods and the related data that operates on those, that those methods need to operate on. If an object maintains particular information, it should be responsible for performing any operations on the data. Keeping information about one thing in one place. Maintenance of specific information should not be shared. So this leads to what we mentioned before, duplicate information and inconsistency. You know, an example could be like the time. Imagine there are two time objects, like time 1 and time 2, and you both ask them the time, and they return different times. I mean, that's horrible. Can anybody think of a way to fix that scenario? There's a way to fix that. Name?
Rory.
Rory.
Could you both put them like through interface first?
Yes, exactly. You could have a situation like time 2 just asks time 1 for the time instead of like producing its own time, for example. So yes, but you're right. They could go through a common interface, which is kind of the same answer. So if more than one object must know the information, then assign the information to one object class, right, that has fewer responsibilities. I always think of the time object for some reason, because that's something you don't want to get inconsistent. All objects requiring that information have little else to do. Perhaps they can be collapsed into a single object. Generally speaking, we just create an object that's responsible for that information. Right? It could be, I don't know, a user, or there are lots of examples. So we could split shared responsibilities. Some responsibilities need to be shared among several classes. They are compound responsibilities like the display drawing, for example. That's like distributing intelligence, preventing centralized intelligence, right? And that can be done by introducing component classes. So subdividing a class into components, or component classes. Okay, we're going to go into this in detail. I guess I'll do this kind of quickly, but we're going to go into this in more detail. Apologies that this is at the end with the last 5 minutes, but this is actually really important. Examining class relationships, a lot of people don't understand this very, very simple concept, including developers, by the way. So there are kind of generic relationships between objects, and we're going to talk about some of them here, right? Some of the generic relationships is a kind of, or is a type of, right? A beginner level player is a kind of player. An advanced level player is a kind of player, right? A lot of people get this confused with is part of. So a beginner level player is a kind of player, and that's expressed through inheritance. But that's not the same as is part of. A beginner level player is not part of a player. You would say something like a hand is part of an arm, right? That's a different kind of relationship, right? And it's very easy to get these confused. Does anybody know how this relationship is expressed in Java? So the first one is expressed with inheritance. How is the second one, how does that show up in Java? It's actually a really simple question. Name? Yusuf.
Attribute?
Yes, exactly. It's a member variable inside. It's a variable inside of a class. That's it. It's a membership. It's a member. Easy to get those confused. I see it all the time, like all the time. If one class is a kind of another class, look for subclasses, superclass relationships. By the way, I'm using redundant terminology here. So subclass and superclass also means child and parent class. Sorry for that. But that's the parent-child relationship. That's just two words for the same idea. Shared attributes or behavior can imply an is kind of relationship. So from the drawing editor class, a text creation tool, a line creation tool can all be kinds of creation tools. They share 3 responsibilities: accepting user input, determining the location of a drawing element, and creating a new instance of a drawing element. Right? So we could introduce an abstract parent class called creation tool and put all those responsibilities in the parent class. Right? Only the second one, however, is likely to be implemented by the superclass, right? If a responsibility is put in a parent class, right, without an implementation, what is that called? If anybody can still pay attention for this long. Yusuf?
Interface?
Interface, yeah, or an abstract method. That's right, that's right. So good job that you can pay attention for this long. I know it's not easy. So the other relationship is composition. Is part of, is composed of, or is part of. And I remember still at my last software development job having a discussion with another developer about organizing classes and their relationships. And I was trying to explain to him, like, actually what you want is an is part of relationship here, not is kind of. And he just said, "You're a loser, Bob." And I was like, "I'm sorry, but that's just the way it is." Like, he couldn't get this distinction clear in his head, the is kind of versus is part of. And I could see it the way he was talking to me. It's just too bad. But you'll see it. You'll see it happen. The objects of one class are part of objects of another class. There's no shared behavior necessarily. There's not necessarily any shared behavior, right? My hand doesn't have to share behavior with my arm. Right? They don't have the same responsibilities. Right? Arm is part of the body, hand is part of the arm, finger is part of the hand. And in this kind of relationship, you can swap parts theoretically. It's not the world's best example, but like the hand knows about the fingers don't necessarily have to know about the hand. So I can theoretically like swap fingers. If I lose a finger, I can put a new one somewhere. But that's a property of this is part of relationship, like swapping parts. And this, to make everything more confusing, this defines an object hierarchy, not a class hierarchy. So you can think of this as an object hierarchy. I would try to avoid those terms. I would say it's more of, like a better phrase would be a composite hierarchy. Or a composition. An object is composed of parts and has responsibilities for those parts, but not vice versa. In other words, like the arm is responsible for the hands, and not the other way around. And I could theoretically like lose my hand and attach a different one, and the arm would still know how to handle the new hand. Not the best analogy, but you get the idea. And this is something about unassigned responsibilities. It can happen that you have responsibilities after identifying them all that you just didn't manage to figure out a good class where they belong. So if you have a responsibility that you can't figure out where it goes, it might mean that a class is missing. Right? So maybe, for example, the drawing editor needs to assign grouping responsibilities. In other words, if you're using a drawing editor, you know that like you can draw a bunch of squares and then you can group them together. Right? That's a mysterious kind of responsibility. What object is going to have that responsibility? Sometimes the assignment is not obvious. Make a tentative arbitrary assignment and see if it works. Like try a walkthrough and see if it works, and update it if you think it's not working. By the way, how do we document our design? This is actually how we document the design. I haven't mentioned this yet. We can document the design using these post-it note style cards called class cards. Right? So we're going from the requirement specification to our design. And the design, the output from the design, does anybody know what the output from the design is, actually? The output from the requirement specification is a document, right? The output from an implementation is a bunch of source code. Anybody know what the output of a design phase is? Besides Sean? Name? Are you the one that did with the quiet voice that I couldn't hear last time? Did you do that one? I can't hear you. Okay. What's the output from the design phase? A prototype. Okay, you could say that's one output. Any other outputs? Sean?
Class hierarchy.
Class hierarchies, yep. A design document is another output. And this is part of the design document, like a class card. It says the name of a class, the parent class, subclasses, and the responsibilities. So that's the first, this is our first view into documenting the design. Like these little, like index cards or post-it notes or whatever you want to call them. That's like the origin, the first steps of documenting the design. Any questions about responsibilities? Objects and responsibilities? Okay, you're free. You're free. Have a good weekend. See you on Monday.